Alright, I just want to show off a new starter I built a few of. They start out as the regular ATV starter motors that a lot of people are using to build starters with. They sell this motor in a lot of different configurations. It looks different because it's been heavily modded and machined, but it started out life as one of the kind with the two lugs up out of these corners, but they sell it, I don't know, several different ways. Lugs out the back here. Another guy makes a starter. He bolts down, the bolts come in from the bottom, and another starter, they use these tabs that were on this motor, but the problem with using those tabs is it puts this power stud sticking out the side, and that's not good because it's always in the way. It's it'd be better if it was up protected by the handle. So I machine those tabs off. I machine the whole motor. We'll get into it in a second, but I'll tell you what all I did to it. It's a lot of work. I'm working on these things for several weeks, but from the factory, I guess you probably know what they look like. With that big snout sticking on the front of the motor. Well, that's where a needle bearing is. But the needle bearing, it has a lot of play in it. And it's just not. I want to get rid of that snout is the main thing. The needle bearing's fine. It doesn't really matter, but ball bearings are probably better. But that's what I did. I went to all ball bearing, stainless ceramic ball bearings. But that snout used to be on the front of it, and it had the O-ring on it. But that was meant to seal the stuff from coming in the front of the motor. But since it wasn't in a housing to use the O-ring that was around this snout, anything could go right in the end of it and get into the needle bearing that was inside of it. The needle bearing used to be up in there, but it was wide open to that. It probably doesn't matter either. You don't get that much dirt in starting your boat with it, but it'd be better if it had a seal. So I sealed it. But anyhow, once I cut that snout off, I lost my bearing up in the front. So I put this stainless ceramic, I bored this oversized to accept the bearing that was made for it. And then the seal, they used to have a seal in here. It was to keep contaminants from coming through the motor into the gearbox. That O-ring on the outside protected stuff from getting in this way, and then the seal that was inside, that same seal was in here. You see, it's a smaller bore, but it was in here before I bored it for the bearing, and it sealed stuff from going through this way. But that don't do us no good for a starter motor. We need to keep stuff from coming in and getting into the bearing, but it doesn't really matter. My bearing was double sealed already. There's a seal on both sides of this bearing, but this just double protects it. I had the seal, it was in here. Why not bore it and put it in there and use it and keep it really clean inside? But that's how that end worked. Now it also had thrust workers, but they're just creating a lot of friction you really don't need. These were all up in here, and then this pushed against it, but it doesn't need that now. It's got ball bearings in it, and they can accept thrust. Not much thrust is from an electric motor really, but it does try to push out the front of the motor can. So I got rid of those. There's a spacer that goes between this snap ring now and that inner race, and any thrust it has, it goes up on that ball bearing. So it's really smooth. I mean, it's working smooth. And then the tail housing now. The tail housing, it had, I don't have one, yeah, there's one in there I can show you, but it had a solid bronze bushing in it. Let me just get this a second. Up in the tail housing, it was an oil light bushing up in here. Well, I knocked it out and got an all stainless ball bearing for that end too in the tail housing. And so armature's fully supported on ball bearings now. And front and the back. So, and then I sent these out and got them balanced. All the armatures are balanced now. And let's see here. So that's pretty much it with the insides. Well, also I studied the motors. Got some bolts in them and stuff, but I studied all of them. It just makes for an easier assembly, a stiffer, just a better motor overall. A studded motor I always liked better than bolts going down through it. So I took some stainless rod and I studded all the motors. You can see they're all studded. And before I did that, I counterboard, and put stainless washers in there so that you have plenty of good solid metal to tighten down on. And aircraft nuts go down on it, and that's what the can looks like. But anyhow, so then in the front of it goes on, and you got a protector to keep the belt on. If you want to use it like that, you can move it to the top hole for the nitro guys, or if you'd like to get the belt on and off, it'll actually sneak in there. You can get it in. It'll sneak right in there like that. But it's to keep the, this is shimmed out. It runs about right there, but it keeps the belt from flying away and coming off and hitting your hand. But it usually doesn't do that. It just keeps it from flying away on you. You have to go chase it, especially if you're starting twins or something. But whatever, it just keeps the belt with the starter if you're getting on a pulley on the front of the motor. But a nitro, I know the belt stays with the boat, and it's got two grooves for if you want to run it slower, blowing water out of your motor or something. You can use a smaller pulley, but and that just keeps the belt from flying. I thought it was good to have. But and what I've done is, since I didn't have the lugs on the motor anymore, it's all machine clean. Had to mount it, so I went through it. 4 stainless bolts threaded to the tail housing, and then there's some aircraft nuts inside, so it's not going anywhere. Then I used all high quality silicone wire, the best I could find. It's, as you can see, it's the good stuff. It's the fine strand, and the terminals are nickel plated steel. They're all soldered. You can see they're soldered. They're heat shrink. They're nice and neat. This is the best way to do the termination. The solder is only on the inside of the barrel. It's not wicked out, so it doesn't make a weak spot where it can dig and break. But all the wiring in the starter is done with silicone wire like this. Anyhow, the power post is going to come up out of the top of the motor now, where it's protected by the handle. The handle will protect everything from shorting or whatever. It's just a little more. And then of course that's going to go on the power stud right there. I haven't run the battery line yet to the battery. I'm waiting on the batteries to get here, and I just don't want to rush it and make it longer than it needs to be or whatever. But the negative wire, the positive, of course, it goes right to the battery. You feed the coil and the relay all the time hot, and then what you do is you ground out the other side of the coil. But just to keep it out of the handle area, I wanted your hand to be able to work all the way back there. But it goes through the back plate. The wire is sleeved in some Viton fuel line, and it goes through the handle. It goes up, goes back through. I'll show you what I did here. Let me show you a piece, one that's not assembled yet. There's the tail of it, and then this gets pressed in it, it gets pressed in. It's a pretty tight interference fit with some Loctite retaining compound. Gets pressed into the handle, and then that screw gets tapped into it. But what I wanted to show you was this groove. That's to pass the wire through to get into the handle. So let me just show you how it works. It comes out of the relay, through the handle, back up through the handle again, through the brace, back plate, I guess you'd call it. And then it goes through there. And then I realized, well, what happens if this thing spins? It's going to shear my wire right off. So I had to do something about that. So I pinned it. It indexes into here and it can't turn now. It's got your perfect little passage for the wire to go through. You can see it goes right in. And once it goes over that pin right there, it can't turn. It's locked in. And then I reduced the diameter on a nice heavy stainless. All the hardware is stainless, everything. And it goes up in there. That nut goes up in there and pulls it all together. And then it goes to your switch and this little ground tab. You just gotta roll that wire up in there and tuck it in, and the ground tab goes in. And then I cut a little notch to key that in, so once it goes in there, the set screw can go all the way down flush with the metal. It doesn't stick up at all. Yeah, I thought that wire got up behind the tail. There you go. Just tuck it in there, and it goes right up in there like that. And the set screw goes down, and that's how that works. So that's pretty much it. But it's going to be a nice piece. But then, while the armatures were out, they were usually raw steel. This is just raw steel, and so I gave them a coat of some high temperature enamel paint. And I reckon that's about it, man. But about the motor again, I didn't really tell you, I shortened it probably by over 1.5 inches. This can, take this off a second here. This motor can, I shortened it. I shortened it 1/8 of an inch on both ends because it didn't need to be as long as it was. It wasn't doing any good. And then I just allowed the shaft to come out the end of the motor out the front farther. And it works out perfect. I got perfect end play. The thrust in both directions, end to end, is thrusting in the ball bearings. It's a killer setup. But let me just pull this apart. I don't want to drop mess up the magnets, but it's that's the tail of it. With the key, it goes together perfect. And then of course the motor drops together. I guess that's about it. All these little adapters, man. There's going to be 3 of them available for sale, but that goes in there in a nice tight fit. I guess I can put the switch in it first and show you how it really goes, but everything is machined to fit nice, tight. Everything is done. I machined the switch down just to give it a better look instead of that cast look, a little billet look to it. But it's all machined nice. Maybe I haven't put the set screw in this one yet, or press the plug in it yet. But that will get pressed in. It gets pressed in there, and then gets the hole drilled in it. A hole drilled in it just to ensure it could never possibly come out, but it gets 648 retaining compound press fit, and it's tight. It goes in hard, so it's right. And these shafts, you know, I cut probably, I don't know how long it was pretty long, but I cut all that off, reduced the diameter. I gotta grind a little keyway, a little notch in there, a little slot for the set screw to sit on yet. You can see I got it, a little mark on it, marked it with the set screw. I just gotta grind out a flat there, and that goes on there nice and tight. There's no play in anything. So that's pretty much it.